Absolute value inequalities. In the previous video, we solved the absolute value equations. In this video, we want to look at inequalities that contain absolute values. Thanks for watching this video and don't forget to like, subscribe to the channel and activate the notifications. It is very important to the continuity of this channel. An absolute value inequality deals with the inequalities on the expressions with absolute value sign. To start, let's first return to the original definition of absolute value. By the definition, the absolute value of a number is the distance of a value from the origin, regardless of the direction. For example, if the absolute value of x is 3, then x equals 3 and x equals minus 3. Now, with this definition and picture in mind, let's see what the absolute value inequalities entail. Let's start off with a simple numerical example. This inequality asks us to find all the x values that are less than 3 units away from 0 in either direction. So the solution is going to set the set of all the points that are less than 3 units away from 0. Looking at the inequality, we see that the number 1 will work as a solution, as will minus 1, because each of these is less than 3 units from 0. The number 2 will work as will minus 2, but 4 will not work, and neither will minus 4, because they are too far away from 0. Even 3 and minus 3 won't work, though they are right on the edge, because this is a less than but not equal to inequality. So graphically, the solution looks like this. The empty circles at the ends of the red line indicate up to, but not including, these points. Once again, let's start off with a simple numerical example. This inequality asks us to find all the x values that are more than 3 units away from 0 in either direction. So the solution is going to be the set of all the points that are more than 3 units away from 0. For instance, minus 4 will work as will 4. Minus 5 will work as will 5. But minus 2 will not work, and neither will 2, because they are too close to 0. Even minus 3 will not work, and neither will 3, although they are right on the edge, because this is a greater than, but not equal to inequality. The solution will be all of the values on the number line to the right of 3 and those to the left of minus 3. Now let's formalize these observations into a more mathematical statements. For all real numbers a and c greater than 0, the following statements are true. We use these properties to solve inequalities that involve absolute value. Let's see how it works. Solve each inequality, graph the solution set on a number line. The absolute value of 3x plus 2 is greater than or equal to 4. This expression has a greater than or equal to sign. Then we will set up a compound inequality that looks like this. Then we will solve the two linear inequalities. Pay attention. The solution set is x such that x is less than or equal to minus 2, or x is greater than or equal to 2 over 3. Look at item B. First, isolate the absolute value expression by subtracting 4 to both sides of the inequality. Since our absolute value expression has a less than sign, we set up a three-part compound inequality as follows. We now solve the compound inequality to get the solution. We isolate the variable by subtracting 1 from all three parts of the inequality. Pay attention. The solution set is x such that x is between -3 and 1. Look at item C. Since our absolute value expression has a less than or equal to sign, we set up a three-part compound inequality as follows. Isolate the absolute value expression by subtracting 7 to both sides of the inequality, and then dividing each part by 2. The solution set is x such that x is between -4 and -3, including these endpoints. Look at item D. Since our absolute value expression has a less than sign, we set up a three-part compound inequality as follows. We will need to be a little careful with solving the three-part compound inequality like this one. Pay attention. Isolate the variable by subtracting 3 from all three parts of the inequality, and then dividing each part by -2. The inequality sign is reversed with division by a negative number. In the final step, don't forget to switch the direction of the inequalities. The solution set is x such that x is between -1 and 4. Look at item E. We already know the answer. Absolute value is always positive or 0, so it is always greater than or equal to 0. It is never less than -5. No values work. The solution set is empty set. Look at item F. This is almost the same as the item E. We still cannot have absolute value be less than 0. However, it can be equal to 0. So this will have a solution only if absolute value of 3 minus 2x equals 0. And we know how to solve this from the previous video. Look at item G. This is almost the same as the item F. We already know the answer. Absolute value is always positive or 0, so it is always greater than -5. All values work. The solution is all real numbers.